Good morning, all. So I think you can hear me. In the last class, we stopped at the point where we discussed about the quality of service in MQTT protocol. So we have been discussing about the MQTT protocol for the last, I think, couple of weeks. So actually, MQTT is one of the IoT-based, IoT particular protocols that are used due to several reasons, such as, reliability of the transmission and the latency. That means that it has, I think, reliability, and it has a low delay in transmission when it's doing the communication. So when you talk about the other protocols that are available, I think we will discuss about the other protocols in the upcoming lecture slides and content. In that we will understand that their protocol has some unreliable features as well in some cases, whereas in MQTT, the MQTT broker is having an organized list of topics that it stores the information under, and because of that, the receivers will get the data in a organized manner. Therefore, I think MQTT broker is playing a significant role in this protocol. So in the last class, in the last section, we have come to the discussion about the quality of service levels. So in the quality of service levels of MQTT protocol, there are basically three types of QoS levels. Basically, these QoS levels are defined to ensure the reliability of the data transfer, and especially for situations where we lose the connection with the broker. So suppose we have a situation where a vehicle, let's say a vehicle is moving under a tunnel, let's say, and first in the initial state, it has the connection with the MQTT broker. The MQTT broker could be a server which is in the cloud, or it could be a local server which is somewhere in the local area. The device, let's say it's a car, and the car's specific device inside the car is connecting to the MQTT broker, and then after some time it loses the connection due to the tunnel conditions, and because of that, MQTT broker is not connected any longer to the car. So in such a case, to ensure that we did not lose any important data, we define these three types of QoS levels. So these three types we discussed in the last class. So basically, there are QoS level 0, QoS level 1, and QoS level 2. I think that we started discussing about these three levels in a slightly brief manner. So today, I think we will go into detail regarding all these three QoS levels, and also understand how it works. I think it's important because when we are using MQTT server, I think last week you must have seen, we can define the QoS level for our MQTT communication. So based on the requirement, based on the application that we are focusing on, we can decide the QoS level under which the MQTT protocol should work. So our communication will be very reliable or very costly based on these QoS levels that we are choosing. In generally, when the QoS level increases, we can see that the cost of that protocol increases, which means that we have to spend, a lot of resources for the communication under QoS level, for example, 2, which is the maximum. So the least costly communication, QoS level is the QoS level 0. So QoS level 0 is very simple, where you only concern about sending the message to the broker. So if you have some temperature data, the client will send the data to the broker, and the broker will receive the data. But in some instances, the broker might not even receive the data. So both things can happen in there. So in the QoS level number 0, you don't know whether the sender will receive your data or not. So that is the main difference in, like, main feature in QoS level 0 when you compare with the other two levels. So what I mean is that you don't have acknowledgement specifically defined for the QoS level 0. For the QoS level 1, we have an acknowledgement message specifically defined, and in this communication, in this QoS level 1 communication scenario, we are sending the message to the MQTT broker as usual. And if some so we have to consider different situations here. So anyway, like, once the packet is received by the MQTT broker, if it receives that, the broker will send an acknowledgement message back to the client, right? And if the client does not receive a certain acknowledgement message after a certain time, after a certain given time, then the client will resend the data back to the broker. So in this case, with the QoS level 1, the client might send duplicates of the same data to the broker, right? So there could be duplicate data transmission to the broker in the QoS level 1. So in the QoS level 2, QoS level 2, what is the difference? So that is what I think we will be discussing more today, about this QoS level 2 and how it differs from the QoS level 1. And likewise, so QoS level 0 is anyway very different from level 1, QoS level 1, because it does not have the acknowledgement feature. So QoS level 2, so it has this kind of a behavior, and basically the MQTT client is sending first the packet of data to the MQTT broker. The MQTT broker, if it receives the data, it will it will send a message which is of type pubrec. So in here, what we mean by pubrec is that publish was received, right? So received is given by rec. So then after the client receives the pubrec, the client knows that its published message has already been received by the broker, and therefore the client decides that it's not going to send its message again to the broker, right? So the client will send another type of data packet called pubrel to the broker, which is a data packet which does not contain the original message, but it contains, it gives the information to the broker that the client will now stop sending the message it has sent earlier, and it's going to release its stored information about the data it sent. Right, so we will discuss about this again if it is not clear to you, right, with a diagram that I can draw in my own drawing board. So the MQTT broker finally sends back a message of pubcom which says that the MQTT broker has received the pub/rel message, and it knows that now the data packet's information has to be released from its own end, and that the communication related to that data packet is now over. It's completed. So pub comp means that the data packet transaction has fully completed, and this pub comp data packet is sent to the receiver, that means the client, to inform the client about that. So in this QoS level number 2, it is known that uh, the MQTT broker will process the data packet only once, right? So that is the main difference between QoS level number 2 and QoS level number 1. Whereas in QoS number 2, the MQTT broker will receive, will process, will process the received message only once. In QoS level number 1, however, you will receive multiple, you will receive the data and you will process the data multiple times. You will process the same data multiple times. So that is the difference between QoS level 1 and QoS level 2. So in cases, so you might ask, why do we need QoS level number 2? And what is the reason for trying to safeguard this one data packet with a lot of verification messages, right? So there could be some instances where we are sending like large data, or data with a large payload, with a big payload or a lengthy payload. So the packet size could be large. In that case, if we have to resend the data again and again to the receiver, whereas in here it's a broker, then it's going to take a lot of time, and a lot of delay is going to get caused, and also the network might get congested if we keep retransmitting a large data or a packet with a large payload. In order to avoid such kind of consequences, the QoS level number 2 is defined to ensure that the MQTT broker processes the data only once. So QoS number level 2 requires a lot of resources, right? Requires a lot of effort when it comes to the other two levels. However, we have to allocate these resources to ensure the quality that is expected from that communication, and therefore all these steps are followed to ensure the reliable communication in this QoS level number 2. So it has a somewhat higher latency than the other cases, right? However, like when we consider high payload scenarios, maybe the latency will actually be lesser in the QoS level number 2 when we compare with the other two cases, whereas in the other two cases, we have to do retransmissions of the data to maybe receive, maybe process the data. So anyway, like this QoS level number 2 tries to process only once the received data, which reduces the processing time, and which therefore reduces the processing delay, and therefore we can reduce the processing delay. However, there could be some added latency due to this added, this additional acknowledgement messages we are sending throughout this verification process, which consists of 4 messages, basically. So that is basically, I think, what we discussed in the last class. We can also discuss about this QoS level further. Also, I think you can go to this website for more information about the MQTT protocol, and you can understand what are the different applications of MQTT in the real world. So right? So this is the mqtt.org website, and it shows like what are the different features of MQTT protocol, and its benefits basically, in terms of I mean MQTT and its advantages in the communication. So it's like as said in this website, there are multiple advantages. It's lightweight and efficient. So we have different, ways of ensuring this lightweight communication. And also we have these topics and data underneath the topics uh, in the MQTT broker, which makes the communication efficient when you compare with the other data communications where you don't know exactly what is the data that is required by the subscribers, right? Sometimes there could be some, sending of the same data to receivers, and the receivers might not even need that data. However, in MQTT, we are efficiently checking out which receivers need that data. And based on that information, MQTT is sending the data specifically to the receivers who required that data, who requested that data, which enables efficient communications. And also MQTT ensures bi-directional communications, which means that like you can do communications from the publisher to the subscribers, and subscribers can also publish data and send that to the initial publishers. So any device who is uh, included in this MQTT communication network can behave as either publisher or subscriber. So we can therefore, we can ensure that we can do bidirectional communication. So we can also increase the number of data, in the MQTT broker, and also we can connect our MQTT broker to millions of devices. So depending on the capacity of the MQTT server, uh, we can connect the number of devices that it can handle. Apart from that, we can also ensure the reliability of the message delivery using the defined quality of service levels, right? And also we can also enable, uh, you know, uh, we can enable uh, you know, uh, some support for networks where we lose the connection with the MQTT broker, uh, and we can solve such kind of issues using, um, using some methods such as like you can change the communication method, and then you can maybe try out different communication technologies, and you can try to fix the communication issue uh, that you face when you cannot connect with the MQTT broker. Then security features also can be included in the MQTT, which means that you can, encrypt the messages you're transmitting to the MQTT broker, and you can use, standard methods to encrypt, such as TLS, and we can actually discuss about those security features in the upcoming sessions also. So security enabled data we can transmit to the MQTT broker. Also, we can ensure the security of the, MQTT server by ensuring username passwords are activated, and only the people who are authenticated can access the MQTT server. So MQTT server has therefore security features, and all in all, the MQTT communication uh, can be uh, uh, can be enhanced with security features, and some of them are like encrypting the messages and then using authentication methods to enable only the specific people to enter the communication. So you can read this website if you can, and you can see the basic concepts related to MQTT protocol. And also you can see how it is used in various industries and their applications. You can go and you can see how they are used in MQTT in different applications. And so you can go into these articles and you can see that. So I think I will share this link in the, maybe in the LMS. In the LMS, I will share this link as a reference, and you can get information regarding that. So I think I will try to now give a summary of the QoS levels again, just to brief that part, and then we will move to the next protocols that are in store for us to study under IoT protocols. So we were talking about the IoT application protocols, and so under that we have discussed about the MQTT protocol so far. And next we have to discuss about protocols such as constraint application protocols, which is known as COAP, and then HTTP, hypertext transfer protocol, and then there are other protocols such as WebSocket, and other protocols are also there. We will discuss about those as well. So, I mean, application layer protocols are what we are discussing so far. So with the MQTT protocol, I think we learned about not only about the theory, but also we learned about how to implement this in the ESP microcontrollers during interactive sessions. So we learned how it can be built like on a system where you set up an ESP microcontroller as the publisher, and then again another ESP as a subscriber, and then how you can connect them using an MQTT broker in between. So MQTT broker acts as the middle person, an intermediate person who receives the data and sends the data to the correct place. So we learned how to set up the MQTT server, and I think we are in the process of getting data communicated successfully from one end to the other end, and from the other end to the initial point. So currently we are learning how to do this implementationally. Therefore, I think MQTT is something that we know both theoretically and experimentally. So I think you can go through this website, and I will upload this in the LMS, and you can go through that when you have the free time. So I think knowing about the QoS levels is a little bit important, and therefore I think I will just go through the QoS levels of MQTT again, just to make sure that we have some initial idea about the MQTT QoS levels. And I think that you need to know about these QoS levels of all the kind of multiple protocols that we are going to discuss about. So the other protocols that we are going to discuss also will have their own QoS levels. So basically QoS level 1, sorry, QoS level 0, QoS levels 0, QoS level 1, and QoS level 2. And QoS level 0, right? QoS level 0 is basically the situation where you transmit the message to a certain MQTT broker, and you do not send an acknowledgement. So I mean, you don't waste your resources to send an acknowledgement. So this sending person, we will name it as the MQTT client. So if it has some kind of a temperature data, the temperature data will be transmitted to the MQTT broker, and the MQTT broker will store the data of temperature inside its server, and it will have its topic temperature in a certain standard manner. And then the data will be collected at the MQTT broker. So in here, the feature is that the MQTT client can, like send temperature data multiple times to the MQTT broker. There could be some situations where the data might get lost. So data losses can occur, and So this is suitable for cases where data losses do not matter much, right? So suitable if the data losses do not impact much, right? Uh, so do not impact much. So, right? So in cases where, for example, I have discussed it in the last class also, in cases where you have temperature data within each 5 seconds, let's say you have temperature data at each 5 seconds. So let's say 5 seconds, 10 seconds, 15 seconds, 12, 20 seconds, 25 seconds, 30 seconds, likewise. And we have some temperature data, let's say 30 Celsius, this is 25 Celsius, again 30 Celsius, then 27 Celsius, 30 Celsius, 31, 32 likewise. And if at some point we will lose the data in between, let's say 27, the output that is received at the MQTT broker might lose the data, which is the data of temperature data of 27. But all in all, the user might not, I mean, the person who has subscribed to this data from this MQTT broker might not uh, notice that, because it keeps receiving all this data, right? So there could be some lost data here, but other data keep continuing all the time. So 32, then afterwards, likewise, for the next 5 seconds, you will receive some other 20, some temperature data. So this data keeps coming continuously, right? Which means that although you lose some data in between, this might not be recognized, not be that much critical, and not be observed as well. And the user might continue seeing the rest of the data. So the user will not, the user will not, the user will not, right? The user might not observe any missing data, right? So it's totally fine in this kind of a case, in this kind of a scenario, to lose some kind of data in between, where you keep continuously receiving, data within 5 seconds or something like that, in a very frequent manner, right? So in that case, like, it's totally fine that you can, if you maintain QoS level 0, right? So in cases where you receive temperature data or some kind of data very frequently, then you might not matter, it does not matter of losing one data. So I will try to, maybe, no, I will keep it maybe. So we will discuss about the QoS level number 2. So QoS level number 1. So QoS level number 1 and QoS level number 2 are like the next steps of QoS levels. So when we discuss about the QoS level 1, we can see that we have the acknowledgement messages, right? So I said that the acknowledgement messages that we have there will be received uh, um, for each message that the MQTT broker received. So let's say there's a MQTT client here, right? There's an MQTT client here. There's a receiving MQTT broker. So in this case, when there's a, right? So when you're sending some data, let's say you're publishing some data, and that published data, once it is received by the broker, a certain acknowledgement message will be sent back to the client. So if in any case the published message is not received, right, then this acknowledgement message will not be sent to the client. So the client will wait for some time, for a certain reasonable time, right? The client waits for some kind of a time, and then waits for a fixed amount of time. And after that time is reached, the client will resend the data, will resend a duplicate of the data. So, right? So once it is sending the duplicate data, that packet will contain something called a duplicate flag, and it will be on. So there are flags inside the packet, I mean contents, right? You can include the duplicate flag there. I mean, there is a specific memory space to include the duplicate flag, its value, and it could be turned on if you are sending the duplicate data. So if you are sending the duplicate data, the MQTT broker will will receive, let's say, I mean, the duplicate data, and once it receives that data, the broker will send an acknowledgement. So what is different here is that although it is a duplicate data, the MQTT broker might not know it is a duplicate data, right? So what I mean is that once a certain data, right, once a certain data is transmitted to the broker will not check the duplicate flag. The broker does not check the duplicate flag, although it has the duplicate flag on. The broker will only, receive the data packet and will just send an acknowledgement regarding receiving the data. So, uh, therefore, like the client might the client might send multiple instances of the same data, and MQTT broker will send acknowledgement for each of those duplicates, right? So MQTT broker will send the acknowledgement for each of the duplicate messages, right? So acknowledgements for each of the duplicates, right? So it does not understand that the duplicates actually are the same message. So it does not check the duplicate flag, although it is there. It does not specifically go inside the data packet and search for the duplicate flag. So the MQTT broker sends an acknowledgement for each of the data it receives. So inside those data that is received, there could be duplicates of the same data. So in this QoS level 1, there could be duplicates of the same data. So therefore, this QoS level is known as right. So there could be duplicates of the same data received at the broker, right? At the broker. So in that case, this level is known as received at least once. So QoS level 1 is known as received at least once, right? So received at least once. So that means that our target is to send the data at least once to the receiver, right? So in that case, like the sender will receive, the transmitting client will transmit multiple times the same data. Right. So that is basically regarding the QoS level 1, where duplicates can happen. So when I move on towards the third one, the third QoS level, right? The QoS level level 2, right? The QoS level number 2 is like a version of the MQTT where you have multiple resources allocated for the communication than the other two QoS levels. So there are 4 messages that are sent in this MQTT level, QoS level 2. So in that situation, we have first the publishing data that the client is sending. So the client will send the publishing data, and the broker will receive either receive or not receive the data. So in that case, if the broker receives the data, then it will send. First, we will consider the case where the broker receives the published data, right? So in that case, if it receives the published data, then it will send a acknowledgement message, right? Which is pubrec, right? Pubrec means publish um, recorded, right? Publish recorded. And then, so if I think, yes, that is how it was, right? want to make sure. Yes, publish received. Public means published received. And thirdly, the client will send the third message, which says that publish released, pubrel. So I think my this diagram is a little bit not clear. So we can get the third message, and it is known as publish released. And then fourth message, which is sent by the broker towards the client, which is known as pubcom. All these four messages will be sent. All these three acknowledgement messages will be sent between these two devices only if we receive the published data initially. So anyway, like all these four messages are required for the communication to complete successfully, and for the communication to happen between them and rely in a reliable manner. So there are many things to consider here, right? So if this published data, which we send initially is not received at the broker, then the client will send the data multiple times to the broker until it receives the public message, right? So what happens with the QoS level number 2 is that if there are if the published message is not received, then the client, right? So the publish is not received, then the broker will not send any acknowledgement message. And because of this, the client will send some data, the client will retransmit the data, same data, again to the broker. The client will retransmit the same data to the broker, and same data to the broker until the client will receive a public message. Until the client receives the public message, right? So in this case, you will ask, like, there's also duplicates happening in here as well when you consider with the QoS level number 1, right? So in QoS level number 2 also, yes, like initially you will be sending some duplicate data to the broker until you receive the public message, right? However, in the QoS level number 2, what is special is that the broker processes certain data only once, right? Processes a certain received data only once. Right? What it means is that so if the broker receives some data, it will process that data only once, which means that it will not process the same data with that certain ID again. So if there are some multiple data that we send with the same message ID, the broker will only process the first message that it received with that certain ID, and it will not process the upcoming data with that same message ID, right? The broker will not process duplicates of the data. It will process only the data that it receives first, right? So it should receive a certain data packet first, and that is the only data it will process. Any duplicates of that same message with that certain ID will not be processed by the broker. So these three handshake messages, they are also essential to maintain that feature in this QoS level number 2. So you will ask, like, how, right? So like if this broker, right? In this MQTT broker, the QoS level number 2, it stores this message ID. until this entire, these four messages are sent back and forth between this client and broker are sent, right? So until all these three messages are sent successfully between these two client and broker devices, the message ID is stored inside the broker, and any messages with the same ID received at the broker will not be processed if it already has processed that. So once all this data, communication has completed, the client will also remove any kind of data regarding this message, right? So if, like, let's say I will take an example, right? I'm trying to send a temperature data, I will say, right? But actually we are sending some other data. Let's say I'm going to send some string data. So let's say I'm going to say some kind of a string, SLTC. And then if I send SLTC once to the MQTT broker, the broker will either sometimes receive it, or sometimes they might not receive it. So if it doesn't receive, the client will send the SLTC message again to the broker. The client will keep sending SLTC message to the broker until it receives a message called public from the broker, right? So once it receives the public message, right? So until it receives the public message, the SLTC message will be sent by the client to the broker. So the broker, finally, if it receives the SLTC data, it will send this message public. It will receive public to the client, right? So once this public message is sent, then the client will stop sending the SLTC data. It will not send SLTC data back to the broker, and it will not send the data again. It will send this data or data packet, which is known as pubrel. The client will send pubrel message to the broker. The broker will receive pubrel message, and broker will know, okay, that my public message was received by the client, and therefore now the client is going to stop sending that data again, right? And therefore I will also stop processing that data again. So the broker up to this point kept kept this message ID stored in the broker, the message ID of the SLTC message, right? It kept it inside the broker's storage. So after the broker receives the pubrel message, the broker will send the final message to the the client, saying that, okay, I'm going to release this message ID, which is corresponding to the SLTC string message, and I'm going to call this communication completed. So once the client receives that pubcom message, the client knows that my SLTC string message has been sent, and therefore I will not send that data, and I will not send that that data again, and therefore that message ID will be discarded by the client and the broker both. So both client and the broker will discard the message ID, and that message ID can be reused by them for another usage in the later instances, right? So this data will be discarded. The message ID will be discarded once the once the pubcom message has been received, right? Yes, so this message ID will be discarded as well by the broker and the client, and the message ID, which is related to this SLTC string, can be used for another instance in the future communications. So once you receive the pubcom message, basically the message ID will be discarded by the broker, and it will be ready to receive any other messages with the same message ID in the future. but that message will not have this data now because the client has discarded this data, right? The client will discard this data, the broker will discard the message ID and the data. The data will be retained, but the message ID will be discarded, and therefore, the client will not send the same data again. The client will send a new data in the next time, and therefore the same data will not be processed again by the broker in the future. So that is basically regarding QoS level number 2. I think that it takes some time to understand this concept. So if you have any questions, you can send them to me, and I will answer your questions. Do you have any questions related to the MQTT protocols, these QoS levels? Right? Can you let me know if you have any questions in the chat, or you can speak up? In the meantime, please mark your attendance. Also, I will share this lecture note with you, with the video that I'm posting, and then you can refer this lecture note and take down your notes. So maybe the QoS level number 2 is not that much clear to you, and then you need to actually look at the definitions related to those QoS level further. So doing that, I will also share with you another reference link that you might find useful to refer the behavior of those quality of service levels. So is it okay if I stop sharing the attendance this link? Do you need it? Are there any more people to send it? Yes, yes, yes. So question is there. I think it's a really good question. So what if uh, the pubrel message, right? The pubrel message. So I think I was discussing about pubrel message, which is sent from the pubrel message, which is sent from the client to the message, the broker, right? So if it is not received, what happens? And then the broker keeps sending public messages to the client until received. Yes. So yes, that's what happens. So the PubRel message, if it is not received at the broker, the client has to keep sending that PubRel message until the broker receives it, right? So there's a specified time limit that is defined for these message transmissions. Okay, so for each message transmission, there's a specified fixed time frame, and if within that time frame we don't receive any acknowledgement from the receiver, then we have to resend that data again after the timeout. So I hope I answered your question, Ediri Singha. Is it okay for you? So I hope you got it, because I think that you have to keep on sending the same data. It could be PubRec, could be PubRel, until you receive acknowledgement data from the other end. So that retransmission will happen after a certain specified time period. So that time period is defined for the MQTT protocol, and that based on that standard time frame, this retransmission will happen, right? So yes, duplicates are received, but the broker will only process the data, the specific information data that it receives only once. In here we discussed about the SLTC string message, so that the string message will be processed by the broker only once. And so if the broker, I mean, the broker might lose the data sometimes, in some cases where we lose the connection between the client and the broker. In such cases, the initial messages of SRTC string might get lost somewhere in the network. But once it receives first at the broker will process that. The broker will keep in its memory the message ID of that string message, and until the pubcom data is sent back to the client, the broker will keep in its store the message ID, and for any future transmissions of this data, of this SLTC string, the broker will not process the SLTC string afterwards anymore. Any duplicates will not be processed by the broker anymore, because it knows the message ID, and if it receives another message with the same ID, it will discard it. So that is how I think basically QoS level number 2 works. And as I said before, if you need more information, I will share with you this link as well in the LMS references. And you can read the MQTT QoS levels and get the understanding through this website link as well. So it explains about the QoS level 0, 1, and 2. So explains how the functions work, and how the how the different messages are sent, what are the protocols, what are the rules that are used in here to uh, complete this communication. So that is basically regarding MQTT protocol, and we will now, I think, move on to other protocols. I think we have discussed about MQTT in a, I think, considerable manner. So in order for us to go to the next protocols, I think we need to discuss about the other protocols that are in the application layer. So when we talk about the other protocols, I discussed with you about protocols such as HTTP, COAP, WebSocket, and there are other protocols also that we will briefly discuss about. So when we talk about the application layer protocols, basically we need to discuss, we are going to be discussing about these 4 protocols. So when we talk about the COAP protocol, before talking about the COAP, we are first going to discuss about HTTP. The reason being that COAP is very similar to HTTP, and HTTP is something that we all know. So HTTP is a protocol that we use to access web resources, so web browser and I mean web resources and the technologies in the web. So HTTP protocol is something that we use daily and we know basically how it works. So based on this HTTP protocol, this CoAP protocol is built on. So in order for us to understand CoAP, we need to have some understanding about the HTTP protocol. So because of this, we will therefore discuss about the HTTP protocol first, and then we will get into the, like CoAP protocol. When we talk about the HTTP protocol, HTTP is used basically for accessing web services and accessing the web resources that are available, and such as like we can access web services such as Google, email services, online shopping, social media, and other types of web applications. So this protocol basically sends an HTTP request message to the server, and the server will reply with HTTP response message back to the client. So this protocol is working under the Transmission Control Protocol, or the TCP, which is in the transport layer, TCP protocol. And so these HTTP protocols are very popular for accessing the web resources. And there are standard ways that HTTP protocol uses to access the resources from the web browsers, right? So when we send the HTTP request, the HTTP request should contain these commands. There are 4 basic commands that we use, and these commands are actually known as request functions of the HTTP. So this the request functions that we use normally are basically get request, which is requesting, used to request data from a server, then post function, which is used to create new data on a server, then put function, which is used to update an existing data on a server, then delete function, which is used to remove data from a server. So these are the basic commands that we use when we are using the HTTP protocol to access some data from the web. So when we talk about the IoT protocols, in IoT protocols, if we can connect our sensors-based embedded systems directly to the internet via Wi-Fi access point, then we can access a certain domain using the HTTP protocol. So the HTTP protocol uses this request message, and it requests for certain a resource in the web, and HTTP protocol does the posting of the data on the web. So if it is used in the post function, HTTP post function is used to update the data in the domain, in the domain, in the server that we are using to update our data into. So HTTP post command is used to update the data there. And then other, like languages are used to, obtain the, data. And at the back end of the server, we can process the data, we can manage the data, we can store the data in a certain database, and then we can use other languages to create web applications that can visualize, that can enable us to visualize the data and show the data through a certain interface. So basically, we can use HTTP post message type to post the data onto the web domain, and post the data in the website. So we have to use specific commands to upload the data. So IoT scenarios can work like this with the use of HTTP protocol, right? So HTTP is the basic protocol that we can use in this scenario. However, in cases where we don't have the internet connection directly, we are going to use the CoAP protocol that I discussed about, which comes in place of this HTTP protocol. So we will discuss about those CoAP protocols and its function after we discuss about the HTTP protocol, and we will discuss about the rest of the HTTP also, I believe, in the next class. So if you have any questions, you can ask. And so I think that would be the end of today's lecture. So thank you so much for attending.